The lab we have prepared today is the Candy Chromatography Lab, and the purpose of this lab is to demonstrate our skills of the separation technique chromatography in order to determine the colors of dye used to color Skittles and the RF values of these dye, which help to determine the polarity of the molecules found in the dye. An important key concept to keep in mind when performing this experiment is polarity. Polarity is used in order to determine the distance traveled by each dye when put onto the chromatography paper. The dye that moves the furthest has the weakest polarity because it is less attracted to the paper. The molecules are less attracted, and the molecules with the highest polarity have the highest attracted molecules to the paper, which means they move less.
For this lab, you will need a 250 milliliter beaker, a strip of chromatography paper, 4 colors of Skittles with 4 of each Skittle, a microwell plate with 4 wells of 1 milliliter water, a number 2 pencil, 0.5 molar potassium chloride solution, 8 toothpicks, and some tape. The first step is to get 75 milliliters of 0.5 molar potassium chloride.
The next step is to take your first color of Skittle, in this case orange, and place it in the first well filled with 1 milliliter of water, and using a toothpick, stir the Skittle until all dye is removed, and repeat this process for the remaining 3 Skittles of that color.
After removing all of the dye from the first color of Skittles, move on to the next 3 colors of Skittles, repeating the same process. Make sure as you remove the Skittles not to drop them into the neighboring wells.
Once finished removing the dye from all Skittles, your well plate should look similar to this.
Using a number 2 pencil, take one edge of the chromatography paper and roll it around and tape that edge to the pencil. Then, about an inch from the bottom of the paper, mark a line with 4 separate dots.
Next, obtain 4 separate toothpicks, each designated for 1 color of dye, and using these toothpicks, place equally sized dots of each color of dye onto the chromatography paper. Once finished with this process, your dots and chromatography paper should look like this.
The next step is to place the chromatography paper in the solution of potassium chloride and allow it to rise until about a 1/4 inch from the pencil.
Next, remove the chromatography paper from your beaker and place it on a paper towel.
Next, lay the chromatography paper flat and measure how far up the solvent had traveled and how far up each individual dye had traveled in millimeters.
Based on the data collected from our experiment, we were able to determine the RF values for each color of candy by calculating the distance the dye moved in millimeters over the distance the solvent moved in millimeters to help determine the polarity of each color of dye. In conclusion, based on these calculations and our data, we were able to determine that the orange candy had the lowest polarity due to its highest RF value, followed by yellow, red, and purple. These results can be generalized in other situations using candy chromatography to determine the polarity of dye in other candies such as M&Ms. Specific limiting conditions for us would include our time, and that may be an effect of our results. And this type of experiment can be used in a practical setting involving crime scene investigations.
In order to determine the percent error, you must take the measured value of the RF over the actual RF value of the dye. A random error that could have occurred during this experiment to increase the percent error would have been an incorrect reading of the ruler measurements while taking the measurements to determine the RF value. A systematic error that could have occurred would be a difference in the concentrations of each dye due to unequal stirring. Methods to reduce these errors would include using instruments or methods that would decrease the inaccuracy of each distance measured and to have a set time for stirring. In this lab, we assumed that the lighter colors would have a higher polarity because we believe that their colors would have faded out long before the darker ones, but that was proven wrong based off of the data that we collected. We were not given an actual RF value of every dye, so we were unable to determine whether or not these measurements were accurate, and due to the time constraint, we were not able to repeat the test any more than one time, so we are unsure whether or not it's precise.